So today's topic is percentage composition, right? Before we talk about this, we are going to revise the concept of percentage. Now, when we have to calculate percentage, now, what is it? That the given value over total value into 100. This is the basic concept of calculating percentage, right? Now we are going to apply this percentage concept in chemistry, right? So what we are going to talk about, like for example, if I have a compound termed um, hematite, or I can say ferric oxide, right? Right? So here what they want that you have to calculate the percentage of iron as well as oxygen in this compound. Okay. So for this, what we will be requiring? We will be requiring the atomic masses of iron and oxygen that we know. So relative atomic mass of iron is 55.85, and for oxygen it is, we know, 16.00, right? So now what about the percentage of iron as well as oxygen, right? Now for calculating the percentage of iron, right, I am going to do very first step is, after getting the atomic masses of the substituent elements which are there in the compound, now we are going to calculate the total mass. Okay, molecular mass of that Fe2O3, right? So this you are going to calculate. So this will be twice of 55.85 plus thrice of 16, right? 0.00. Now you have to tell me what it is going to be there.
159.7.
159.7 gram per mole, right? So this is what I got. Now, for calculating the percentage of iron, now I have got the total atomic mass. And what is the mass of iron present in this compound? That should be twice of 55.85, which is around, I think, 111.7.
Yeah, 100. Yes.
0.7, right? So now, percentage of iron given mass, the mass of the iron which is found in the compound, which is 111.7 over total mass of the compound into 100. So can you calculate this for me?
69.94%.
Okay, 69.94%. So this percentage is of iron, right? Now we have only two components or two elements which are there in the compound. So we can calculate the percentage of oxygen by two methods. First is, you are going to follow the same procedure. You're going to calculate the mass of oxygen present in the compound, then divide it by the total into 100. But yes, we have to do the smart work. So what we are going to do, because we know the total percentage always remains 100. So we are going to subtract 69.94 from 100 in order to get the percentage of oxygen. Is that okay? Right? So what will be answer of this?
30.06.
30.06% is of oxygen, right? This is how we are going to calculate. Okay, now let's see. Okay, the next question we are going to do. Okay, you have to calculate the percentage of nitrogen in the fertilizers. So first of all, let me clear this thing. So this will be like helpful in, clearing the concept. Right? Okay. Now, first of all, we have the formula, which is NH4 whole twice SO4. This is ammonium sulfate, and I need to calculate percentage of nitrogen. Okay. First of all, calculate the molar mass of ammonium sulfate, okay, which will be twice of nitrogen plus 8 times of hydrogen plus 1 time of sulfur plus 4 times of oxygen, right? And along with this, we are going to calculate mass of nitrogen present in this, which is twice of the mass of one atom of nitrogen. Okay, just do the calculations. Mass of nitrogen present in compound over molar mass of compound into 100. Yes, so you have calculated?
Yes.
Yeah, tell me.
The total molar mass is 132.154.
Yeah,
And then the mass of nitrogen is 28.0202.
yeah, right. So now we are going to put the values over here over 132.154 multiply by 100. So calculate the percentage.
21.20.
21.20% is of nitrogen, right? So if I tell you, see in the question, it was just written that you have to calculate the percentage of nitrogen, but I want you to calculate the percentage of sulfur, then percentage of nitrogen, sorry, hydrogen, nitrogen though we already have done, and last is percentage of oxygen in the same compound. Okay, so I'll wait for your answer. Yeah, tell me.
For sulfur, it's 24.27%.
Okay, right.
And then 6.10.
10 for hydrogen.
Yes.
Yeah.
And then oxygen was 48.43.
0.43. So if we are going to add up these percentages now, we are going to get 100%, right? So if in case in the examination you're asked about any of the elements, so you can calculate it, right? Right? So let's move on. Okay. Now the next concept is if I have to calculate the formula, right? Now they have given us a journal, if a compound is there and you have got to make calculations a little bit easier. So just a second, I'll let you know with the help of a compound. Okay. Sometimes the direct formulas, they do help us. But according to me, the concept also should be clear because if in case we forget the formula, we have the basic concept with us, which is going to help us in any way, right? Now see, if I have a compound named like this, that means there are three elements in the compound and they have this various coefficients, the number of atoms, right? So percentage of A will be calculated as W into relative mass of atomic mass of A, right? Into 100 over molecular mass of, so this is the same thing which we were doing, right? It's the same thing, but they have given us in the form of a formula, right? So if it comes up like as a question, so don't get panic. It is the same procedure which we are following. Okay. Now, if you are given any experimental data and we ask you to calculate the formula, like I gave you some percentages, right? Or I gave you some measured amount of the compound, then can you make the formula of that compound? Yes, it is possible, but it is possible by using two concepts of mathematics. Number one is your percentage, number two is your ratio, right? we know when we started doing chemistry, when we're talking about the compound, what we said? We said that in the compound, the elements are found in a particular ratio by mass, right? So we are going to stick to this basic definition and we are going to frame up the formula. Let's see. First of all, we are going to do the example and then we are going to proceed on to the unsolved also, right? So I'm going to erase this because at this moment we don't need, right? Chale. Okay. Now, what we are given? We are given lithium when 4.97 gram of lithium metal reacted with oxygen, excess of oxygen, it was converted into lithium oxide, okay, Li2O, right? And the amount of Li2O was, sorry, I am not supposed to write the formula. Like we are going to erase this, otherwise this is not a good suspense, right? Okay, so we got the result as lithium oxide, and the amount of lithium oxide formed was 10.89 gram. Okay, now we have in lithium oxide, we have only two elements. One is lithium, the other is oxygen. So they have given the mass of lithium, but they have not given the mass of oxygen. So how we are going to calculate?
Uh, 10 point.
Calculate.
Yeah.
We are going to subtract
No.
this. Yeah. Today there is some internet issue like popping up and we are like, okay, so this comes out to be 5.92 gram. Okay. Now I have got the mass of lithium. I have got the mass of oxygen. Now what to do? See, now what is the molar mass of lithium? Do you remember?
There's 6.941.
Okay. And for oxygen, so you must be remembering
16.00.
16. Yeah. Now, see, we can do one thing. We are going to convert these masses into moles. Okay. First step is we are going to calculate the number of moles of lithium, which is the given mass over the molar mass. Okay. And then oxygen, which is given mass over its molar mass. So would you calculate this?
For lithium, it's 0.716.
Yeah. And for oxygen?
Oxygen, it's 0.37.
0.37. Okay. Now, this first step is clear.
Yes.
Now, the next step. Out of these two moles now, which we have got, the lesser one will be dividing both of them. Means, in case of lithium, we are going to do 0.176 over 0.374. And for oxygen, it will be 0.370 over 0.370. So this so comes out to be 1, right? And this is, can you calculate this? Because this is not a pure number. I can see the example,
One
but I want you to do the calculations. Yeah,
1.935.
935. So here we are going to round it off to 1.94. Again, we are going to round it off and I'll be getting 2 as the answer. So there are 2 moles of lithium combining with 1 mole of oxygen. So leading to the formula Li2O. Got it?
Yes.
Yes. Now, see, I can tell you one more method to write, but just a way of presentation. Uh, so whatever you feel easier, you can do that. Actually, I prefer doing it in a column method. Column things make the calculations look easier. Otherwise, they're not easier, but yes, they will look to be easier. Like, for example, I'm going to write lithium oxygen. Then I'll put a column. Then I'll write the percentage, which I have, right? Here I don't have the percentage. I have the mass, right? So I'm going to write the mass, which is present, right? This was given. Then I will write down their atomic mass, right? It is 6.941 and it is 16.00. Then I'm going to make the column for the number of moles. Here I'm going to get like uh, 4.97 over 6.941. So this is going to give me 0.716. Here 5.92 over 16.00 is going to give me 0.370. Then I'm going to use the concept of ratio. So it is 0.716 over 0.370. Here 0.370 over 3.70. The simplest ratio comes out to be 1.94 and it is 1. So rounding off gives me 2 and 1. Right? Otherwise, we can even multiply. If I'm not getting, just for example, here it was 1.5, here it was 2.5. So I can multiply both the numbers with 2. Because in the compound, there is always a whole number ratio, right? There is no fractions or points, right? So the formula comes out to be LiO2. Is this clear? Right.
Yes.
Now, we are going to do the next question and you're going to frame up the formula. Okay, the next question says, 0.84 gram of zinc, right? It reacted with chlorine gas, okay? And zinc chloride formed was 1.7 gram. You have to calculate the formula of zinc chloride, okay? So start doing.
Here we go 1.75.
So our formula comes out to be ZnCl2 after following all the procedure, right?
Yes.
Yes. Okay. So now the formula which I am getting now, this is the simplest formula. Like this is the simplest ratio in which a compound will be found, right? The elements are found. So it is called empirical formula, right? It is just telling us the ratio in which the atoms will be present. But sometimes, na, like for example, if I talk about organic chemistry, like I have C4H8, I'm not going to get this kind of formula from this method. This is your molecular formula, right? I'll be getting the simplest ratio, which means CH2. This I'll be getting by using this method. So CH2 is basically your empirical formula, right? It is giving me the basic ratio which is found in between the atoms of like different elements which are found in the compound. Got my point? And then we are going to multiply it with some number so as to get the molecular formula, right?
Yes.
So, yeah, we are not going to get the molecular formula like this. So first of all, we are going to practice for the empirical formula. And when we are very well in empirical formula, then we are going to do the molecular formula. Okay. Okay. The next question is also very interesting. There are two questions, so we are going to do that quickly. Okay. Okay. One is an example, but you're not supposed to see the solution. We are going to calculate everything, right?
Yes.
Yeah. Okay. Now question says there is a chlorofluorocarbon CFC 113, right? It was used as the coolant in refrigerators, but is now banned because of the ozone hole scenario. So on analysis of this, we have the mass of like the sample is 2.37 gram. And what we got to have 1.36 gram of chlorine, right? And 0.71 gram of fluorine. Okay, this is what we got. Now, obviously, the leftover thing will be of carbon. Okay, so now you have to calculate the empirical formula of this compound. Okay, so ready for the challenge? Yes.
Yes.
Okay, that's pretty good. So I'll wait for your answer.
But I station
Yeah, what's the mass of carbon?
the mass is 12.01. Oh, the mass 0.3.
0.3. Okay. Okay.